We're going to look at solving trig equations today. Now, your degrees are typically not what you answer these in. If it's not specified, use radians. If it specifies degrees, then do that. If it doesn't specify, then use radians. Now, keep in mind that our trig functions repeat every time you go around the unit circle or their period of their trig functions, so you can have multiple answers for each one of these. Now, looking at this first one, you're dealing with a cosecant. Now, you're not used to having stuff for cosecant memorized, so I would try to switch it into stuff you're supposed to have memorized, which are sines, cosines, and tangents. So I'd rewrite this as a 1 over a sine is equal to our root 2. Now, being a fraction equaling a fraction, you could either cross multiply, or since your sine's on the bottom, you could just flip both sides upside down. If you flip both sides, you get this. Now you're not used to the root being in the bottom, so we rationalize it, and now it's in a form that you're used to dealing with. So you got to ask yourself, sine of what angle is root 2 over 2? Well, you should know that the sine of pi over 4 is one of our answers. Now, it's really sine of pi over 4 plus any full revolution thereafter, so we go plus 2 pi n, because a full revolution is 2 pi, and any number of full revolutions after our pi over 4 would put us at the same spot and have the same y value. But then you got to think, on my unit circle, where else is sine, which is the y value in my unit circle, at that same height of root 2 over 2? And that is at 3 pi over 4 plus any full revolution thereafter. So both of your answers would be these two here. So here we have cotangent equaling this. Now, a lot of people look at this and they get confused and they actually think, did I say cotangent? Cosine is equal to this. A lot of people think this. The black statement and the dark blue statement are totally different in meaning. The black statement I wrote, you're told your angle and you just want your cosine, which is your x-coordinate of that spot. Where over here, you're looking for the cosine of what angle gives you the output of this, which this is then your x-coordinate because it's cosine. Well, remember pi is a little bit more than 1, or not more than 1, more than 3. A little bit more than 3 divided by 3 would be a little bit more than -1 in this case. So remember, your cosine graph only goes up to a height of 1 down to a depth of -1. Or cosine on your unit circle only is dealing with your x-coordinate, only goes to the right of +1 and to the left of -1. So it'll never get to this. So it's really the empty set. So over here, we want to try to get the sine by itself. So we'd have to get rid of the adding of root 2 and get rid of the timesing by 2. So we'd subtract our root 2 from both sides, divide both sides by 2. Now that your trig function is on one side by itself, then you can go ahead and ask yourself, sine of what angle is equal to negative root 2 over 2? Well, your angle is equal to sine at two different spots, or your sine of your angle is equal to negative root 2 over 2 at two different spots. One of them, because sine is the y value, is in the third quadrant, and one of them is in the fourth quadrant. Root 2 over 2, remember, is your pi over 4, so it's at 5 pi over 4 and at 3 pi over 4. So you got to take whatever your angle is, which in this case is 3 theta, equal to each one of yours answers. And remember, we have this 2 pi n because it's any multiple number of full revolutions thereafter. So now we got to finish getting theta by itself. So we'd have to divide by 3 or multiply by 1/3. And so we would get this, and we would get this. Remember, you're doing it to this fraction and that fraction, so you're doing it to everything. So make sure you have this one right here affected. So we need to solve this one for cosine. And in this case, our cosine's already on one side by itself. We have a big ugly angle afterwards, but your cosine's by itself. So you got to ask yourself, cosine of what big ugly angle gives me that root 2 over 2? Well, when is cosine equal to root 2 over 2? It's at pi over 4 plus any full multiple revolution thereafter. Now notice that this right here is my angle, what was after the cosine. And then I got to go my angle, what's after the cosine, equal to the other time when cosine's equal to root 2 over 2, which is at 7 pi over 4. Then I'd have to go ahead and add pi over 4 to both sides of this, add pi over 4 to both sides of this. Now here it says start at 2 pi and add any full revolution of that. Well, if I'm at 2 pi and I keep adding 2 pi, I'm still really dealing with just any multiple of 2 pi. So this right one here, we really simplified down to just this. The left one over here, we didn't do anything to. Now at this point, we can multiply both sides by 1/4 to get rid of times equal to 4, or divide by 4. Either way, we would get this, and we would get 2 pi n over 4, which is just pi n over 2. So we need to get the trig function by itself. So we got to get rid of the positive 3, we got to get rid of the negative, and we got to get rid of the squaring. So we could take our tangent squared to the other side, and then it would be equal to 3. Then we could get rid of the squaring by taking the square root of both sides. And when you take the square root, you need to remember plus or minus. So you got to ask yourself, when is tangent equal to positive root 3? And when is tangent equal to negative root 3? And once again, those are ones you're supposed to have memorized. So when is it equal to positive root 3? That's at pi over 3. Plus your period, and the period of tangent is pi. So we go pi over 3 plus our period of pi n. Now we don't list the other spot on our unit circle where it's equal to root 3. So we don't have to worry about 4 pi over 3. Because yes, it's equal to 4 pi over 3 for your angle whenever tangent's equal to root 3. But because it's pi over 3 plus pi n, so pi over 3 plus 1 pi would be that 4 pi over 3. So it's just the first time where tangent's equal to this. Also, when is tangent equal to negative root 3 over 3? Well, that's at 2 pi over 3 plus your period after that. And once again, we don't have to be concerned about the second time it's equal to negative root 3 over 3 on your unit circle, because we're adding 1 pi, and 1 pi plus that takes care of that second spot. So here we just have a quadratic, because we have one term squared and one term to the first power. It's not necessarily quadratic with 3 terms, but it's still quadratic. Remember, in solving quadratics, you want to have it set equal to 0 and factor, or set equal to 0 and use a quadratic formula. In this case, we do have a common factor, which is our greatest common factor. We pull that out and we look at what's left. So now we have two things multiplied together to give us 0. So the purples either have to be equal to 0, or the blue would have to be 0. So purple's equal to 0, you get tangent of your angle by itself, so you'd have to subtract 1 from both sides. So now you got to ask yourself, when is tangent equal to 0? Well, that's at any multiple of pi, because it's at 0, pi, 2 pi, 3 pi, so on. When is tangent equal to negative 1? Well, that's at 3 pi over 4 plus your period of tangent, which is pi, or any multiple of your period after that. So that's pi n. Here, this is quadratic. You have your term to the second power, that same term here, plus a normal number. Since we have 3 terms, we could try factoring by our AC factoring, with A being 2, C being negative 3, do our AC factoring, or you could do the quadratic formula If you did the quadratic formula, remember you're always solving it for the smaller of the two exponents. This one does factor quite nicely, and we would get this. You now have the red times the blue to give us 0. The only way that can be true is if the red is equal to 0 or if the blue is equal to 0. Then we could easily solve the blue by subtracting 2 from both sides. Then we could easily solve the red for the sine of u by adding a 3 and dividing by 2. Now remember, sine and cosine, when you look at their graphs, always go from a maximum of 1 to a minimum of -1. So they're always between 1 and -1. And in this case, sine is equal to -2, which is not between 1 and -1, so it's the empty set. Similarly over here, we have our sine equal to 1.5. Well, remember, sine is always between 1 and -1, so it's never going to get to 1.5, so it's an empty set. These are both empty sets, so therefore your overall answer is empty set or no solution. Looking at this one here, we're probably going to want to try to do some simplifying before we're actually able to answer the question and solve it. So on the left-hand side, I'm going to probably turn everything into sines and cosines and do the same thing on the right side. We have a sine plus a cosine, and then we have a cotangent, which remember is cosine over sine. On the right side, this is just 1 over sine. Now over here on the left side, we have a fraction times a fraction, so you multiply the top, multiply the bottom, and here we have this on the right side. Now you'll notice that our common denominator is sine of x. So we could multiply everything by the sine of x. Sine of x, sine of x, and sine of x. Multiplying everything on both sides by the sine of x. So we get sine times sine, or sine squared. Here your sines drop and leaving you with a cosine squared. Over here your sines drop, leaving you with 1, which in this case is our Pythagorean theorem identity. We know that sine squared plus cosine squared is equal to 1. So it's going to be all real numbers. Except, look here, we have variables in the bottom. So it's going to be all real numbers except what would cause the bottom to be 0. So you got to think, when is sine equal to 0? Well, sine's equal to 0 at 0, then on the other side of the circle at pi, then all the way around to 2 pi. Oh, so at 0, pi, 2 pi, 3 pi, 4 pi, so on. So basically any multiple of pi would cause the bottom to be 0, which would be undefined. So our answer is going to be all real numbers except what causes the bottom to be 0, which is any multiple of pi. So we have one more problem. The expected low temperature in Fahrenheit in Fairbanks, Alaska is approximated by this sine function, where t being 0 corresponds to January 1st. We want to know for about how many years or days of the year is the low temperature below 4 degrees Fahrenheit, -4 degrees. So that means our t right here is -4. So if I plug in -4 for my t, then all we have to do is solve this. Now, we could also go ahead and graph this to give us a nice visual from what we were doing in the last chapter. You know your amplitude's 36, you have a vertical shift of 14, you have a phase shift of 101 days, and your period is affected by this value of b. So if you graph it, you get this red graph down here. And it makes sense that our period is 365 because it's 365 days in a year. We also have our -4, and we're wondering how many days we're below. So in other words, that is how many days we're below, which would be here, and how many days we'd be below, which would be here. That's really what we're looking at visually. So if we go ahead and graph this, we'd have to solve it for sine. So we got to get rid of the plus 14 and the 36. So we're going to subtract 14 from both sides. Then we're going to go ahead and divide everything by 36. So now we have the sine on one side all by itself. So now we got to ask yourself, sine of some big ugly angle to give us negative 1/2. Well, when is sine equal to negative 1/2? Well, that's our big ugly angle equaling to 7 pi over 6. And our big ugly angle equaling 11 pi over 6. Now, we don't necessarily have to go plus 2 pi n on each one of these. Could we? Yes. But remember, we're trying to figure out for one full period. So really, that's what I'm dealing with, because one full period is 1 year, and we're looking for what's going on in 1 year. Now, if we do exact answers, we're going to get some really messy fractions, and we're looking at days, so we're going to want kind of whole number days. So first of all, I'm going to start out by doing some decimal approximations. So I'm going to go and get rid of this by multiplying both sides by 365 and dividing both sides by 2 pi. So if I take this times 365 divided by 2 pi, I get about this. Same idea over here for this one here. I got to multiply this by 365 and divide it by 2 pi. And I would get this. Now, I want to go ahead, oh, I got a typo here. This is supposed to be 101, not 1 minus 1. I need to go ahead and get each one of these where t is on one side by itself. So I got to add 101 to both sides here, add 101 to both sides here. So this is about 213. If I add 101, I get 314. This is about 335. If I add 101, I get 436. Now 314, that's within 1 calendar year, but 436 is more than 1 calendar year. So I can go ahead and subtract a full period, which is 365, and I get 71. So that means my 71 right here correlates to here. So during these first 71 days, it would work. Also, what I have right here correlates to 314. So I would then need to still find how many days are afterwards here. So I would have the first 71 days, and well, let's see, it's 365. To get the purple, it would be 365 minus the 314. That would be 51 days. So the first 71 days and the last 51 days work for us. So the total number of days would be our 71 plus our 51, or 122 days.